Welcome to the Coco YouTube channel. Subscribe to our channel to watch new videos like this. New exploration and PC demonstrating show that volcanic movement may have happened on the ocean bottom of Jupiter's moon Europa in the new past, may in any case be occurring. NASA's forthcoming Europa Clipper mission, focusing on a 2024 dispatch, will dive near the frosty moon and gather estimations that may reveal insight into the new discoveries. Researchers have solid proof that Europa harbors a gigantic sea between its frosty outside layer and rough inside. The new work shows how the moon may have sufficient inner warmth to incompletely dissolve this rough layer, a cycle that could take care of volcanoes on the seafloor. The new 3D demonstrating of how this inner warmth is created and moved is the most definite and careful assessment yet of the impact this inside warming has on the moon. The way into Europa's rough mantle being adequately hot to dissolve lies with the gigantic gravitational draw Jupiter has on its moons. As Europa spins around the gas Goliath, the frosty moon's inside flexes. The flexing powers energy into the moon's inside, which then, at that point, leaks out as warmth. The more the moon's inside flexes, the more warmth is created. The exploration, distributed as of late in geophysical research letters, models exhaustively how Europa's rough part may flex and warmth under the draw of Jupiter's gravity. It shows where warmth scatters and how it dissolves that rough mantle, improving the probability of volcanoes on the ocean bottom. Volcanic action on Europa has been a subject of hypothesis for quite a long time. By correlation, Jupiter's moon Io is clearly volcanic. Many volcanoes there emit magma wellsprings and launch volcanic gas and residue up to 250 miles high. Action that is because of a similar sort of inner warming brought about by Jupiter's draw. In any case, Europa is farther away than Io is from its host planet, so researchers have contemplated whether the impact would be comparable under the frigid surface. Driven by Marie Bunkova of Charles University in the Czech Republic, the creators further anticipated that volcanic action is well on the way to happen close to Europa's posts, the scopes where the most warmth is produced. They likewise took a gander at how volcanic movement may have developed after some time. Seemingly perpetual fuel sources offer more chance for possible life to have created. Submerged volcanoes, if present, could control aqueous frameworks like those that fuel life at the lower part of Earth's seas. On Earth, when seawater comes into contact with hot magma, the collaboration brings about compound energy. Also, it is substance energy from these aqueous frameworks, instead of from daylight, that helps support life somewhere down in our own seas. Volcanic action on Europa's ocean bottom would be one approach to help an expected livable climate in that moon sea. Our discoveries give extra proof that Europa's subsurface sea might be a climate appropriate for the rise of life, Bunkova said. Europa is one of the uncommon planetary bodies that may have kept up volcanic action more than billions of years. and potentially the just one past Earth that has enormous water supplies and an enduring wellspring of energy. Direct observations. NASA researchers will have the chance to scrutinize the new expectations when Europa Clipper arrives at its objective in 2030. The rocket will circle Jupiter and perform many close flybys of Europa to plan the Moon and research its piece. Among the science information it gathers, the shuttle will study the surface exhaustively and test the Moon's dainty environment. The surface and environment perceptions will allow researchers an opportunity to study the Moon's inside, see if the water permeates up through the cold outside layer. Researchers accept the trading of material between the sea and the hull would leave hints of seawater on a superficial level. They likewise accept the trade may radiate gas, and perhaps even tufts of water fume, with shot-out particles that could contain materials coming from the ocean bottom. As Europa Clipper estimates the Moon's gravity and attractive field, inconsistencies in those spaces, particularly toward the posts, could help affirm the volcanic action anticipated by the new examination. The possibility for a hot, rough inside and volcanoes on Europa's ocean bottom builds the opportunity that Europa's sea could be a tenable climate, said Europa Clipper project scientist Robert Pappalardo of NASA's Jet Propulsion Laboratory in Southern California. We might have the option to test this with Europa Clipper's arranged gravity and compositional estimations, which is an energizing possibility. More about the mission. Missions, for example, Europa Clipper help add to the field of astrobiology. The interdisciplinary examination on the factors and states of far-off universes that could hold on to life as far as we might be concerned. While Europa Clipper isn't a daily existence identification mission, it will direct nitty-gritty observation of Europa and research whether the frigid Moon, with its subsurface sea, has the ability to help life. Understanding Europa's tenability will assist researchers with bettering life created on Earth and the potential for discovering life past our planet. Overseen by Caltech in Pasadena, California, JPL drives the improvement of the Europa Clipper mission in organization with the Johns Hopkins Applied Physics Lab in Maryland for the office's Science Mission Directorate in Washington. The Planetary Missions Program Office at NASA's Marshall Space Flight Center in Huntsville, Alabama, executes program the executives of the Europa Clipper mission. Thank you so much for joining our video. Subscribe to our channel to watch new videos like this. Don't forget to share the video with your friends.